Alright, so this video will focus on 2.1 and corresponding sides. So the very first thing is the essential questions, and it says, how could you identify congruent triangles? So that's kind of the focus of our entire lesson today. The first thing we're going to look at is these geoboards, and it says here, work with a partner and look at these various geoboards, and it says form each triangle in a geoboard and then measure each side with a ruler and record your results in the table. And what conclusions about the side lengths of triangles that are congruent? Well, as you start measuring these things, and it's kind of hard on diagonals, but I'll teach you a way later on how to solve this. But as we use the ruler and start figuring out the various side lengths here, you're going to notice that they're exactly the same for the congruent ones. And so you go through here and you can actually go and measure these. And I'll quickly just get a quick ruler here. So if I take, let's say, this one here, and I measure this side length here, and I'm going to look at the hypotenuse, meaning the longest side. So that's what I'm going to be measuring, the hypotenuse. So I go over here, and I start at the 0, and then I move up a little bit. It appears that this is around 4. And then I look at all the other ones and see if I can find the same hypotenuse of 4 as well. So I'll go back through. And this hypotenuse here is a little bit less than 4. This one here is a little bit more than 4, it looks like. This one here is a little bit less than 4. This one here is exactly 4. So it appears that these two here are congruent, for sure, because the hypotenuse is the exact same length. Now when you start measuring the various sides, you might see other ones that are also congruent. But now if I look at the pegs, look at this. If I go up 1, 2, 3, and over 1, and if I go down 1, 2, 3, and over 1, and then this one I'm going to go over 1, 2, 3, and up 1, and this one I'm going to go down 1, 1, 2, 3. So my lengths here are exactly the same size on both of these, and that's partially why it's congruent. And that's what the conclusion is. For something to be congruent, the side lengths have to be exactly the same. Basically that you could fit one thing on top of another and it will look exactly the same. So it says now form the yellow triangle on activity 1 on your geoboard, record it, and then move the vertex 1 unit to the right. So if I take this and move every one of these little bands 1 unit to the right, will it be congruent? And the answer is yes. Whenever I measure the sides, you'll notice that they're exactly the same length, and the angles are exactly the same as well, because I'm moving everything one direction to the right. And that's called translating it to the right. So the next one says 3 different examples of congruent figures or objects in the classroom. You have to look around and do that, but there's a lot of them. If we look at this here, we're going to look for shapes that are exactly the same, meaning I can fit them right on top of each other, and it will fit exactly. So if I look here, I'm going to take this and I'm going to say color one of these in. So I'll go down here, go over here, go over here. This is not perfect, of course, but now if I move this, I can tell that this is significantly bigger. Therefore, these are not congruent. Again, it's poor drawing, but you get the idea. Same with this one. If I would draw this out, and I draw it here, again, I'm using a mouse, so it's not the best, but if I move this over, you'll notice that this takes up less area on this one than this one here. So these are not congruent either. I'll then go to this one. Shift it over, and it's bigger than this one, so not congruent. This one here is a little bit trickier. We'll see what this one is. So if I take this, and for this one I have to actually flip it around, right? But if I take it, this one looks pretty close. In fact, I'm going on a limb here to say that it is congruent. I just drew it poorly, but very, very similar. I could pretty much fit this on top. Now I'm rotating it, but it still fits on top. This one here, if I would go through and try to figure out if this is exactly the same, so I'd go through here, and then move it down and rotate it. This one too is a little bit smaller, right? And then finally this one here. I'll rotate it around. Again, it's not the best drawing, but we get the idea. If I look here, I think if I would draw this properly, it would actually work. So I'm going to say that this one here is congruent. This one here is congruent. So that's how you actually go through and do this. So then the key idea, which you should have written down in your book, corresponding sides. So it says figures have the same size and shape are called congruent figures. I'm going to underline these things here. So same size, same shape, and they're called congruent figures. If you look here, I can match up the corresponding sides. So B corresponds to E, C corresponds to F, and A corresponds to D. It's basically what are the same on both of these. So this angle measurement is exactly the same as this one. C is exactly the same as F, and A is exactly the same as D. Because if I would move this figure over, it would fit exactly on top here. So now we have to go through here and name the corresponding angles and the corresponding sides. So if I look here, this corresponding angle on this one here would be W. If I look at B, that corresponds to X. If I look at Z, that corresponds to D. And then finally, C corresponds to Y. Now it asks for side lengths as well. And when I do that, we're going to write this down as side length, and I'll put down A, B, corresponds to W, X. You're going to notice a couple things here. Number one, I started off with A, and that corresponds this A here, and the one below it is W. So that's why I had to put a W down here first. And then I go to B, so it's going from A to B, just like this is going from W to X. So this is an example of one that works. A non-example, one that does not work, would be A to B is X to W. This is a no-go. This does not work because of the fact, let me just mark this off, because I started off with A and I went to B, so I went from left to right, and on the other one I went from X to W. Although the line is the same, I'm not putting the proper order, therefore it is not correct. So the key idea here, two figures are congruent when corresponding angles and corresponding sides are congruent. You're going to notice a couple of things. Notice these little symbols here. So the little thing here, this like angle 1, and I put an angle 1 here. Then there's two little marks here. That's the 2 down here. And then the 3 marks correspond to this. That's for the angles. For the side lengths, you're going to notice there's a 1 hash mark here and a 1 hash mark here. These sides correspond to each other. Notice how there are 2 here. It says 2. That's why this is also a 2. And the bottom one is 3, and that's why the bottom one here is 3. So it says which square is congruent to square A? Again, congruent means same size and same shape. Now they're all the same shape, all of them. But which one is exactly the same size as square A? Well, B is 9, and these are 8, so it would have to be C. We're going to do the same thing here with the trapezoids. So it says here that they are congruent. So what's nice here is I know that the side lengths that correspond, BC will correspond to KL. Therefore, this one over here will be equal to 6 as well. This is 8. So side length BA corresponds to KJ. So this is 8. LM corresponds to CD. So this is 8. And AD corresponds to JM, which means this is 10. So once you know what they correspond, it's pretty easy. Now we have to figure out the perimeter, so the distance around. We'll take 10 plus 6 is 16, plus another 16. 8 plus 8 is 16, so altogether that equals 32. It says draw triangles and quadrilaterals exchanged with a partner, and then make a congruent figure. And this is your homework. So this is the presentation.